I am going to present a simple proof that the direction of the electric force between two charged particles lies along the line connecting them. So to start out with, I'm going to have two source charges, which I'm going to arbitrarily call Q1 and Q2. And I'm going to draw the line connecting them. These are particles, so I don't have to worry about center-to-center distance and radii and so forth. It's just the distance between these two particles. And I'm going to use the line connecting them as an axis, which I'm going to extend in both directions. And now we're going to rotate this charge distribution around that axis. Now, I hope it's obvious to you that rotating this charge distribution around that axis doesn't change the way the charge distribution looks. It looks exactly the same. So here we see an example of a symmetry, which basically means that I can do something to my system and the system not change. So here I've rotated my system around an axis and it looks the same before and after the rotation. So let's assume that the force on Q2 due to Q1 does not lie along that line. In other words, let's assume it has a non-zero vertical component so that I have to draw it like this. If I were to now rotate this charge distribution around the same axis that I used before, we would now find that although the charge distribution looks exactly the same, the force doesn't. So we've broken the symmetry. So either it must be true that space is not isotropic, or that the force on 2 due to 1 cannot have a vertical component. And the isotropy of space is well established by experiment. And it would be sort of silly to abandon that. So we're left with the realization that the only possible direction that F21 can have is along the line joining the two charged particles.